Hi everyone. In this lecture, we are going to focus on the nomenclature of alkanes and cycloalkanes. Alkanes and cycloalkanes are the compounds that comprised of just carbons and hydrogens, no other elements and no pi bonds. We also call them hydrocarbons. For example, we have this compound that's the simplest of all alkanes that has one carbon and four hydrogens, and we call them methane. And the next simplest alkane is ethane that has two carbons and six hydrogens, no pi bonds, no other elements. So if you look at the suffix of these compounds, the names end with ane, A-N-E, and we follow the system called IUPAC. If you look at the table, we have a list of hydrocarbons with number of carbon atoms from 1 through 10. The hydrocarbon with carbon number 1 is called methane. Hydrocarbon with carbon number 2 is called ethane. And then we have propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Depends on the number of carbon atoms in the compound. Now, how to name the complex alkanes? Let's start with an example. We have this compound. It has branches and it has many carbons and hydrogens. So to name this compound, we need to follow a system. Okay, let me go step by step in naming this compound. The first step of naming a compound is choosing the parent chain, and here the parent chain should be the longest chain. The chain that is highlighted red is the longest chain in that structure, and we can name the parent chain based on the number of carbons that was given in the previous table. This chain has 9 carbons. Name of this parent chain is nonane. So now look at the examples in the bottom. They are both same compounds. I just drew that twice. In the left side structure, that's this one, and in the right side structure, it's a different chain, but they both have same number of carbons. If you count the number of carbons in that highlighted chain, the left side structure has 7 carbons and the right side structure also has 7 carbons in that longest chain. So which is the right parent chain here? We need to count the number of substituents attached to that parent chain. And the red one is parent chain and the green ones are substituents. Those are the branches attached to the parent chain. And if you count the number of substituents on the left side structure, we have 3 substituents attached to the parent chain on the left side structure, and we have 2 substituents attached to the parent chain in the right side structure. The parent chain that has more number of substituent is the right parent chain. So we need to rewrite the statement. Choose the longest chain that has more number of substituent as the parent chain. Okay. So if you look at the 2 examples in the bottom, the left side structure has 3 substituents, so that's the right parent chain, not the one on the right side structure. Okay. Let's do a small quiz on this. If you have clicker remotes, if you are ready, let's start the quiz. Identify the correct parent chain for the following compound. Okay, your time starts now. Remember the step number 1, it says the longest chain in a molecule is the parent chain. We close this polling in 5, 4, 3, 2, 1. Let's look at the students' response for this question. Okay, 160 students said A is the right answer. Okay, the key says A is the right answer. If you look at the choice A, there are 4 substituents attached to the parent chain. In choice B, you have only 2 substituents, so obviously A is the right parent chain. Let's move on to step number 2 in naming the alkanes. Step number 2 is name the substituents. The name of the substituents should end with the suffix YL. For example, we have this compound, so that's the parent chain. Step number 2 says name the substituents. We have the first substituent that has two carbons. Two carbons is eth, and since it's a substituent, it should end with the suffix YL. So the name of the substituent here is ethyl. And the second substituent has three carbons, so we call that propyl or propyl. And the third substituent is methyl. Okay, now let's look at another example here. We have a cycle and we have a chain here, and the first step is to find out the parent chain, right? In this case, we should count the number of carbons in the cycle or in the ring and the number of carbon atoms in the chain. Okay, one of that is going to be the parent chain. Let's look at the ring. That's a ring that has 6 carbon atoms. So here the ring has greater number of carbon atoms compared to the chain. So the ring is going to be the parent. And since it has 6 carbon atoms, we call that hexane. And since it's a cycle, we call that cyclohexane. And that's going to be the substituent. It has 3 carbon atoms, so we call that propyl. Okay, let's look at another example. Here, the compound has a ring and a chain, and again, to find out the parent chain, you need to compare the number of carbon atoms in the ring and number of carbon atoms in the chain. The one that has more number of carbon atoms is going to be the parent here. It's not like the linear structure. In the linear structure, you just you count the number of carbon atoms. The longest chain is the parent chain. The longest chain with more number of substituents is the parent chain. But since it has this compound has a ring and a chain, you compare the number of carbon atoms in the ring and the chain. Okay, if you do that, the chain has greater number of carbon atoms, right? The chain has greater number of carbon atoms. There are 4 carbon atoms in the chain, and there are only 3 carbon atoms in the ring. So the parent is going to be the butane, the chain, and the cycle is going to be the substituent here. And since it has 3 carbon atoms, we call that propyl. And since it's a cycle, the complete name of the substituent is cyclopropyl. Okay, very good. And let's go further and name the shorter chain substituents. Right, so the shorter chain substituents have some common names that you need to memorize. The common names are very popular, and the IUPAC accepted to use the common names. So let's look at these two structures here. So there is a parent and you have a substituent, and the two substituents in the two compounds, they both have 3 carbon atoms, right? The left side structure has a linear substituent with 3 carbon atoms, and the right side structure has a branched substituent with 3 carbon atoms, right? And the first substituent is called propyl, we know that, and the second substituent here is called isopropyl. That's new, right? So if 2 methyl groups are attached to a carbon that has a hydrogen, we call that iso. Okay, if you look at this carbon right here, it has 2 methyl groups and a hydrogen, so we call that iso. And since the total number of carbons is 3, we call that isopropyl. Right, so one is propyl, another one is isopropyl. and the IUPAC name of the branched propyl is 1-methyl ethyl. That's the IUPAC name. But we can use the common name because the common name was accepted by the IUPAC. Okay, so you need to memorize the common names also. Let's look at a few more examples here. The substituents are butyls. They have 4 carbon atoms. So each substituent in this example has 4 carbon atoms. So the first one is linear and all other substituents are branched. The first one is called butyl. And if you look at the third one, the third substituent, it has something similar to the isopropyl, right? The 2 methyl groups attached to a carbon that has a hydrogen atom. Okay, so if you look at this carbon atom, it has 2 methyl groups and a hydrogen atom. So we call that iso. And since the total number of carbon atoms is 4, we call that isobutyl. Okay. And the second substituent is called secondary butyl or sec-butyl. The parent is attached to the second carbon of the butyl. We call that secondary butyl. And the last substituent is called tertiary butyl or terbutyl. 3 methyl groups are attached to a carbon atom. That's called ter or tertiary. And let's look at a few more examples here. We have substituents with 5 carbon atoms. The first one is linear, the other 2 are branched. The first one is called pentyl. Second one is called isopentyl. Again, if you compare the structure with previous iso structures, they all have methyl groups, 2 methyl groups attached to a carbon that has a hydrogen. Okay, and the last one is called neopentyl. Okay, 3 methyl groups attached to a terminal carbon, and the total number of carbon atoms are 5. And the name of that substituent is neopentyl. You got to memorize this. Yeah, these are common names, and there is no system, there is no steps to follow. So you got to memorize these simple names of the substituents, right? Okay, now have your clicker remotes ready. We're going to have a quiz on this second step of naming alkanes, right? Okay, now the quiz is: choose the correct name of the following compound. You have a cycle, you have a chain. Choose the correct name. Okay, your timer starts now. Polls are coming in very fast. I'm going to close the quiz in 5, 4, 3, 2, 1, 0. Okay, now let's look at the students' responses here. 165 students, that is 83% of students, says B is the right answer, and 21 students, or 11% of the students, says C is the right answer. 14 students said A is the right answer. So let's look at the answer key. Okay, yeah, B is the correct answer. And the ring has the more number of carbon than the chain, so the ring is going to be the parent chain, and it has 6 carbon atoms and a cycle. So name of the parent is cyclohexane. That's going to be the suffix of the name, and name of the substituent is secondary butyl, right? So that's the prefix, and the complete name is secondary butyl cyclohexane. Okay, now let's move on to step number 3 in naming the alkane. Step number 3 says number the parent chain. Let's look at an example here. So these two are same compounds. I have drawn that twice, and you have a parent chain with 1, 2, 3, 4, 5, 6, 7 carbon atoms, and you have a substituent with 1 carbon atom. And in the left side structure, I'm going to number the parent chain starting from left to right. Okay, so if you do that, the substituent is on the second carbon. The location of the substituent is 2. On the right side structure, I'm going to number the parent chain from right to left. Okay, let's do that. Right to left. Now, the substituent gets the location 6. Otherwise, the substituent is attached to the 6th carbon if I do this numbering. Okay, the statement here is assign the lowest possible number to the substituent. Okay, so the left side structure has number 2, or the location 2 for the substituent. The right side structure has location 6 for the substituent. The correct one is on the left side. Okay, the substituent should get the lowest possible number, or lowest possible location number. Right. Now let's do a little more complex here. Let's try a little more complex structure here. We have a structure with a parent chain. Okay, let me draw that twice. We have a parent chain that is highlighted red, and it has 7 carbon atoms, and we have few substituents. They're all methyl groups, right? On the left side structure, I'm going to number the parent chain. I'm going to number the parent chain from left to right. And on the right side structure, I'm going to start my numbering from rightmost carbon atom to the leftmost carbon atom of the parent chain. And if you compare, if you look at the location of the substituent, on the left side structure you have a methyl group on number 2, carbon number 2, and you have 2 methyl groups on carbon number 5. Okay, so that's okay. On the right side structure, you have a methyl group on carbon number 6 and 2 methyl groups substituted on carbon number 3. And the statement is, the rule is, you got to assign the lower possible number, or the lowest possible number, to the first substituent. Okay, so if you look at the previous statement, it says assign the lowest possible number to the substituent, and to be accurate, we need to rewrite the statement and say assign the lower possible number to the first substituent. Okay, we have 3 substituents in each structure. On the left side, we have substituent, the methyl group on carbon number 2, 5, and 5. Okay, there are 3 substituents on the carbon atoms. On the right side structure, we have substituents on carbon number 3, 3, and 6. If we compare the first number, it should be the lowest number. The lowest number is the right way of numbering the parent chain. Okay, the first number should be the lowest number. So the left side way of numbering is the correct way of numbering. Okay. Now what if there is a tie for the first substituent? If there is a tie, if the first number is same, like if the first number is 2 for the left structure and 2 for the right side structure, then you got to go for the second number. Okay, if there is a tie for the first substituent, then the second substituent gets the lower number. Okay, fine. Now we also look at the number of times the substituent appear on the parent chain. Okay, so if a substituent appears more than once, it gets a prefix. For example, in the bottom examples, we have methyl groups that appeared 3 times, right? So it gets a name, it gets a prefix tri, tri, tri. And if a substituent appears 2 times, it gets a prefix di. And if it's 4 times, then it's tetra. And if a same substituent appears 5 times, we got to give a prefix penta. Okay, right. And let's name the top example, the top structure. 2 is the location of the substituent, and methyl is the name of the substituent, and heptane is the name of the parent chain. And the complete name is 2-methyl-heptane. In the bottom example, we have substituents located in 2, 5, 5 locations, and the name of the substituent is trimethyl because it appeared 3 times on the parent chain. Okay. Trimethyl is the name of the substituent, 2,5,5 is the location of the substituent, and heptane is the name of the parent chain. So that's the complete name for this structure. Right? Now let's move on to step number 4. That's the final step. Okay, step number 4 is place the substituents in, again I need to check the spelling for substituents. Place the substituents in alphabetical order. Right? Okay. So when you write the complete name of the compound, and if the compound has more than one substituents, we need to assign them in alphabetical order. And when you do so, you should not count the prefix di, tri, tetra, or penta. You should not count that. Okay. Let's try an example here. We have this complex structure with a parent chain, and so the step number 1 is name the parent chain. The longest chain here has 8 carbon atoms, so the name of the parent chain is octane. And the second step is name the substituents. Here we have a methyl, and another methyl, and an ethyl. There are 3 substituents based on the name of the substituents, or again based on number of carbon atoms. Right. Now step number 3 is number the parent chain, and again remember that the first substituent should get the lowest possible number. Okay, so how do you number this parent chain? From left to right or right to left? Correct, left to right. Number the chain so that the first substituent gets lower possible number. Okay, now name of the first substituent is 2,3-dimethyl because the methyl group appeared twice on the parent chain, so it's called 2,3-dimethyl. And the second substituent is called 4-ethyl since it has 2 carbon atoms and located on the 4th carbon of the parent chain. Okay, now what's step number 4 say? Place the substituents in alphabetical order. What does that mean? When you write the complete name of the compound, you got to arrange the substituents in alphabetical order. Here, if you look at the names of the substituents, ethyl starts with E, and dimethyl has M for methyl. So again, you should not count the di, tetra prefix. Okay, so E versus M in alphabetical order. E comes first. So 4-ethyl, 2,3-dimethyl, octane. Octane is the number of parent chain. right? So that's the complete name of the compound. There are 4 steps, and you got to follow the 4 steps when you name the complex alkanes, right? Now congrats, you just mastered the nomenclature of complex alkanes. So let's go further. Let's name little more complex hydrocarbons or alkanes, right? So what are bicyclic compounds? That's a cycle, we know that, and it has 6 carbon atoms, so we call that cyclohexane. Now what if you have a bridge between carbon number 1 and carbon number 4, right? So there is a bridge. Can you see that? There is a carbon that bridge the first and fourth carbon of cyclohexane. So it's called a bicyclic compound. It has two rings fused together. Okay, and if you want to look at the 3D structure of that bicyclic compound, it should look like this. And if you have iSpartan app on your iPad, open your iSpartan and draw the cyclohexane and bridge the carbon number 1 and 4. And look at the 3D structure of that. Okay, so open your iSpartan. Okay, so now let's come back to our nomenclature. How to name it? How to name the bicyclic compound with 2 rings fused together? Okay, we can say bicyclic heptane. It has 2 cycles, so bicyclic, and it has 7 carbon atoms, so heptane. Is it okay? No, it's not enough, because we are going to look at some examples here which says that bicyclic or bicycloheptane is not just enough to name these compounds. Okay, here is an example. Here is another example. They both have 7 carbon atoms and in the first structure, the bridge is between carbon number 1 and 4. In the second structure, the bridge is between carbon number 1 and 3. Okay, to differentiate these 2 structures, these 2 compounds, count the number of carbon atoms in each bridge. Okay, and I just said we have 7 carbon atoms in each of these structures. So bicyclic heptane is not just enough. We need to give some number to this name to differentiate these 2 structures. Okay, now how to number it? How to differentiate these 2 compounds? Let's look at the steps here. Step number 1: identify the bridge heads. So these are the 2 carbon atoms where the bridges start. So we call that bridge heads. Bridge heads. Okay, and the second step is count the number of carbon atoms in each bridge. The first bridge has 2 carbon atoms. So if you go from one bridge head to another bridge head, you have to cross 2 carbon atoms. Okay, so that means you have 2 carbon atoms in the bridge. And the second bridge also has 2 carbon atoms, and the third bridge has 1 carbon atom. Right? So the name should be bicyclo and 221. That's the number of carbon atoms in each bridge. And then heptane, the total number of carbon is 7, so it's heptane. So bicyclo square bracket 221 heptane. Right? If you look at the second structure, these 2 are the bridge heads. The green ones are the bridge heads. And the first bridge has 3 carbon atoms. If you go from one bridge head to another bridge head, you have to cross at least 3 carbon atoms, right? So that's the first bridge, the longest bridge. The longest bridge is the first bridge. And the second bridge has 1 carbon atom, and the third bridge is also have has 1 carbon atom, right? Now what's the name? Right, bicyclo square bracket 311 heptane. Bicyclo square bracket 3.1.1 close the bracket heptane. Right, so if you look at the numbers, you should always arrange the numbers from larger to smaller number. Okay, so that means the longest bridge is the first bridge and the shortest bridge is the last bridge. So these are the bicyclic compounds without any substituent. So that's the parent chain or parent structure. And you all know how to name the parent structure. Now let's go to bicyclic compound that has some substituents. Right. So here is an example. There is a bicyclic parent chain with a substituent, a methyl substituent. And here is another example that has the methyl substituent at different location. Now how to name these two? Let's follow the steps that we just saw in previous slide. Step number 1, name the parent. Okay, to name the parent, you need to identify the bridge heads. Bridge heads are the carbon where the two bridges are fused together. Okay, so these two carbons are the bridge heads, and start counting. Okay, so these are the bridge heads, and start your name of the parent with bicyclo square bracket and count the number of carbon atoms in the longest bridge. 1, 2, 3. There are 3 carbons in the longest bridge, so 3. And count the number of carbon atoms in the second longest bridge, 1 and 2. So you have 2 carbon atoms, 2, and count the number of carbon atoms in the shortest bridge, 1 carbon atom, and close the square bracket. And octane is the total number of carbon atoms in the parent chain. So that's the name of the parent chain. Name of the parent, I shouldn't say that chain because it's a cyclic compound, so it's the name of the parent. Now how to name the substituent? For that we need to follow the step number 2. Step number 2 in naming the bicyclic compounds is number the carbon atoms in the cycles starting from one of the bridge heads. Right? You can start from either one of the bridge head in this structure. Let's start from start from one of the bridge heads, and the longest bridge first and the shortest bridge last. Okay, we are going to number the carbon atoms from one bridge head to another bridge head. So we are going counterclockwise, 1, 2, 3, 4, 5, one bridge head to another bridge head, the longest bridge first, right? And continue the numbers to the next longest bridge, 6 and 7, and continue the number to the shortest bridge, 8. So there are 8 carbon atoms starting from one bridge head, go through the longest bridge and then second longest bridge and then shortest bridge. Right, there are 8 carbon. Now what's the name of the substituent? Methyl, we all know it's the name of the substituent. What's the location of the substituent? Yes, carbon number 8. Right, so step number 3 is locate and name the substituent. Here it's methyl, and the location is 8. So the name of the substituent is 8-methyl. Good. Okay. Now let's go to the second example here. We have two bridgehead. So bicyclo, square bracket, number of carbon atoms in the longest bridge is 3, and the second longest bridge has 2 carbon atoms, so 2, and the shortest bridge has 1 carbon atom, so it's 1. Close the square bracket, and octane is the number of 8. There are 8 carbon atoms in total, so it's octane. So this is the name of the parent chain, bicyclo 3,2,1 octane. So step 1 and 2, or step 1 is good. Now what is step number 2 says? Number the carbons starting from one of the bridge heads and go through the longest bridge first and then shortest bridge last. Okay, now watch the direction of numbering. I'm going to count the number in 2 different directions, so watch the direction. 1, 2, 3, 4, 5. Starting from one bridge head, going through the longest bridge, 1, 2, 3, 4, 5 in counterclockwise. Now if I do so, now your methyl group is on the 7th carbon, right? The location of the methyl group is on the 7th carbon. That's the second longest bridge. But if I start from the other bridge head, instead of going counterclockwise direction where I get the location 7 for methyl group, let me start from the other bridge head, going counterclockwise. 1, 2, 3, 4, 5. One bridge head through one bridge head to another bridge head through the longest bridge. Now your methyl group gets carbon number 6, right? So that's on the second longest bridge. If I continue numbering, the second longest bridge gets 6 and 7, and then the shortest bridge gets 8. So now the substituent is on location number 6, that is 6th carbon atom. Which one is best? Counterclockwise or clockwise? Right, the clockwise, because we try to assign the lowest or lower possible number to the substituent. The location of the substituent should be lowest possible number. Okay, so in this case, the name and location of the substituent is, the location and name of the substituent is 6-methyl, and the name of the parent is bicyclo 3,2,1 octane. Right? You all with me? Good. Now let's do a clicker quiz on this. So have your clicker remote ready, and I'm going to start the quiz. Right. Choose the correct name of the following compound. You have a bicyclic compound with 2 substituents, and there are 4 choices. Your time starts now. Right, polls are coming in fast, and I'm going to close the polling in 5, 4, 3, 2, 1, 0. Okay, now let's look at the students' responses. So 110 students said C is the right answer. 49 students said A is the right answer. 40 students said B is the right answer. Okay, let's look at the answer key. Okay, C is the right answer. 5,5-dimethyl bicyclo 2,1,1 hexane. Okay, so again we have to follow the steps. Step number 1 is naming the parent, and here all 4 choices have same parent name, so we are good. And if you look at the step number 2, number the bridges going from longest to shortest from one bridge head. So start the numbering from one bridge head, go through the longest bridge, 1, 2, 3, 4, and now the second bridge and third bridge, they both have equal number of carbons. That's one carbon in each bridge. Okay. Now we have to assign the lowest possible number to the substituent. That's step number 3, right? Okay. So if we do so, the second bridge is going to be the bridge that has 2 methyl groups. Okay, so give the smallest possible number for the substituent. At the same time, you should not violate number 2. You should always start your numbering from one bridgehead, go through the longest bridge, and then second longest bridge, and then the shortest bridge. Okay, without violating that rule, at the same time, give the lowest possible number to the substituents. So the right answer is C, 5,5-dimethyl bicyclo 2,1,1 hexane. Okay, good. So we are at the end of the lecture. You're all good. You just mastered the nomenclature of alkanes, cycloalkanes, and bicyclic compounds. So next week we are going to look at the conformational analysis of alkanes and cycloalkanes. Believe me, it's going to be more fun.